South Africa, and in the hills just outside Johannesburg, staff at this plant manufacturing medical radioisotopes are preparing molybdenum. It's to be transported to the United Kingdom. There, in the form of technetium-99, it'll be used in hospitals as a life-saving diagnostic tool. More than 15,000 kilometres away in the northern plains of Canada, the day is drawing to a close. Here at McArthur River, the world's largest uranium mining operation goes on 24/7. This uranium ore is the raw material for the fuel used in nuclear power plants, generating electricity to meet the world's ever-growing energy needs. "13,000 kilometres west is the island of Singapore. Here it's mid-afternoon. This is the busiest port in the world. From here, a company based in neighbouring Malaysia is shipping radioactive sources to Australia. They'll be used to check the integrity of international oil and gas pipelines. This film tells the story of how these materials are transported worldwide in a manner that is closely regulated by national regulatory bodies with the support of the International Atomic Energy Agency. This ensures that the transport process is three things: safe, secure, and sustainable. The molybdenum manufactured here in South Africa is a radioactive substance that, in certain forms, decays in a matter of hours to technetium-99, a substance that's used as a radioactive tracer to diagnose the malfunction of organs in the human body. The substance is heavily shielded to prevent the irradiation of operatives, handlers, and the public. Packaging for radioactive material is designed using what is called a graded approach. The greater the hazard presented by the material, the stronger the container. This one's rather like a Russian Matryoshka doll, where, as in this case, one container nestles inside another container, which itself is inside another container. Because of molybdenum's short half-life, there can be no hold-ups, no delays on its journey. The clock is ticking. "640 metres underground at McArthur River in Saskatchewan, a drilling and reaming operation produces heaps of uranium ore. These are mixed with water to make a slurry which is then pumped to the surface. The slurry then begins its long journey by road to a series of processing plants, from which refined, enriched uranium eventually emerges in pellet form. The pellets are inserted into fuel rod assemblies, ready for use in nuclear power plants. The mine achieved international standard certification in 2003. It's one of a very limited number of sites in the world where uranium can be economically mined. On the outskirts of Malaysia's capital city, Kuala Lumpur, this facility services the company's clients throughout Malaysia, Indonesia, Thailand, Singapore, Korea, and Australia. It provides the radioactive sources used inside pipeline survey pigs to detect flaws and fractures in gas and oil pipelines. It's work which helps to maintain the security of the energy supply all over Southeast Asia. Today, they're preparing 4 such radioactive sources to be transported in an overpack by road to a freight company in Singapore. Here they'll be placed in a container ready for loading onto a ship bound for Australia, where the tracer will be put into use. Packages of radioactive material must be checked for activity before they're shipped. This is both to ensure that the radiation dose rate at the surface of the package is within the limits prescribed by the regulatory authorities, and to check for incidental surface contamination. This helps ensure the safety of cargo handlers. Radioactive material is on the move around the world all day, every day, 24/7, 365 days a year. Although the general public tends to focus on the transport of nuclear fuel, especially spent fuel, in fact such movements account for little more than 5% of all radioactive consignments. Every year, about 20 million packages are routinely transported by road, by rail, by sea and by air. They're classed as dangerous goods by the United Nations, which issues regulations to prevent such goods of any nature from harming people, property or the environment. No movement of this material is permissible without strict adherence to these regulations. Radioactive material is designated Class 7 dangerous goods by the UN. Back at the facility in Kuala Lumpur, the package sources are being loaded into an overpack, which later will be loaded into a shipping container for the voyage to Australia. The main guarantee of safety in the transport of radioactive material is the packaging. Like the special container we saw earlier, this is designed in accordance with the IAEA's regulations, which are themselves developed in close consultation with IAEA member states. All package types are tested to ensure that they withstand fire, impact, wetting, pressure, heat and cold. As the degree of hazard from the different sorts of material transported varies considerably, so too does the packaging. The radiation trefoil has to be applied to all packages and marked with a UN number assigned to the material. The type of label gives an indication of the radiation field in the vicinity of the package. This is for the purposes of safety and security. On the other side of the world, in South Africa, a van has arrived to take the molybdenum, shielded in its packaging, to Johannesburg Airport. The package has already been sealed to prevent tampering. Now, as is required worldwide, the vans are carefully placarded. Road vehicles must have placards on either side and at the rear of the vehicle, carrying the trefoil symbol and the UN class number 7. This shows that the vehicle is carrying radioactive material. The movement of radioactive material is strictly governed by regulations produced by a section of the United Nations, the nuclear watchdog, the International Atomic Energy Agency. It's based in Vienna. First published in 1961 and being continuously updated, the regulations for the safe transport of radioactive material have been widely adopted by both national regulators in countries all over the world and by modal organizations like the International Maritime Organization and the International Civil Aviation Organization. These requirements are also incorporated into the UN Orange Book, the model regulations for the transport of dangerous goods. Guidance published by the IAEA aids member states with the implementation of the requirements codified in the regulations for the safe transport of radioactive material. Implementation of these requirements ensure that those involved in the transport of such material, the general public along the routes where the goods are transported, and the environment generally are all protected from radiation. They cover all aspects of transport operations, including labelling and documentation, dose rate limits and activity limits for packages, requirements for the establishment of radiation protection programs and the provision of training, and the design and testing of packages. Of course, the safety and security of the movement of radioactive material also depends on people. The centralisation of standards through the IAEA helps ensure a consistent level of understanding of the risks posed by this material worldwide. People handling this material are trained to know the hazards that arise from handling it, to know what precautions to take, and to know how to respond in an emergency. A recent survey found that most transport workers involved in radioactive material receive a higher level of exposure from background radiation than from their work. It's because of the high level of regulation and high level of training that the safety record for the transport of radioactive material is as good as it is. When the South African paperwork is complete, these urgent medical supplies can depart for Johannesburg International Airport. Note the endorsement by the Radiation Protection Officer. Although not required by the regulations, as an extra security precaution, this consignment is accompanied all the way to the airport by an armed escort. The tracking of each and every consignment is meticulous. The consignor, the consignee, the freight handler and transport company all have to ensure that every time a container of radioactive material is transferred from a ship to a train, from a truck to a plane, at any time in any place in the world, the progress on its journey is recorded into the computer tracking system. It means that at no time can the consignment become unaccounted for. A similar truck with the sources from Kuala Lumpur is arriving at a freight handling company in Singapore, where the overpack will be placed in a container before going to the docks. And back in MacArthur River, the uranium ore is also on the road to Key Lake, where it will be milled. The road connecting the two plants is 78 kilometres and cuts through what at minus 30 degrees in winter can be a very inhospitable landscape. It's not unusual for the truck drivers to see bears on their daily journeys. At 1 million Canadian dollars a kilometre, the road complies with the construction standard laid down for a government provincial secondary highway. Incidentally, the dust thrown up, of course, isn't radioactive. A full-time maintenance team ensure the road is kept in first-class condition. At every point in the transport process, the risk to the handlers, the public and the environment is minimised. For reasons of both safety and security, the drivers of such vehicles are given special training and observe numerous checks en route. On this particular journey, they report their progress as they pass each 10-kilometre marker post. It means that at any one time, all the road users know where all the trucks are.
Security, kilometer 40 south, security.
Here in Singapore, the four sources from Kuala Lumpur are padlocked to steel eye bolts set in concrete inside a secure compound, which is itself locked. while they await onward transport to the docks. Security is tight. The alarm here runs straight through to the local police. As in this case, radioactive material is often carried by companies that specialize in the transport of dangerous goods. They have highly trained staff working at premises like these with safe and secure storage facilities. Meanwhile, the radiopharmaceutical package is arriving at Johannesburg International Airport. The cargo handlers are trained in the processing of such packages and are aware that it poses no danger to them, provided they're appropriately handled. Here at the airport, the package is stored in a safe dedicated to radioactive material until it is ready to be loaded onto the aircraft bound for the United Kingdom. Radioactive cargoes are often carried in the holds of passenger aircraft. The International Civil Aviation Organization regulates the transport of these packages. In northern Canada at Key Lake, the truck with the uranium slurry has completed its 78-kilometre journey and goes straight to the unloading bay. Video cameras guide the pipes, which will pump out the slurry straight onto the ball valves. It means that no humans have to go anywhere near the cargo. Unloading is fully automated. At London's Heathrow Airport, the radiopharmaceuticals from Johannesburg have just touched down. As the world's busiest international airport, Heathrow handles a large number of radioactive packages every day, reflecting the very widespread use of these materials. From medicine to agriculture, from research to manufacturing and industry, radioactive material is everywhere. A tiny radioactive component is an essential part of the smoke detectors found in tens of millions of homes all over the world. Radioactive material is used in many light bulbs, for sterilizing food, for measuring the thickness of paper, for treating cancer. Uses too numerous to mention all of them here. From the aircraft on the apron, the radiopharmaceutical package is taken to a freight warehouse, where it will be held until the truck arrives to take it to the town of Amersham, 30 kilometres northwest of Heathrow Airport. There it will be prepared into the product, which will be delivered to hospitals all over the United Kingdom. In a matter of hours, it has had to cover more than 9,000 kilometres, because the plant outside Johannesburg is one of only a handful in the world that produces this vital diagnostic tool. Now safely under lock and key in a dedicated holding cage, it's only another hour or so to its next destination. Here at Key Lake, the uranium slurry is being processed through a series of tanks, leading to the production of yellow cake, a powdery uranium concentrate. Yellow cake leaves here in drums. An automated system fills the drums, which are then checked, sampled, labelled, and loaded into a truck, which will set off on a road journey across Canada to a processing plant at Blind River, Ontario. There are some 435 nuclear power reactors in 30 countries, but only a few countries have geological uranium deposits available for mining. If nuclear power plants are to continue providing much needed energy, the transport of nuclear material is essential. Again, this material is very carefully labelled. Drums are always stacked on the trailer deck, never on top of each other, and bound together with a heavy-duty steel binding. Wooden battens nailed to the deck ensure nothing can move on the long journey. Back in Singapore, the industrial tracers are being loaded into a container for onward transport to the port on the southern tip of the island. Great care is taken to secure the overpack inside the container. In the United Kingdom, in Amersham, the source, packaged in Johannesburg, arrives from the freight warehouse at Heathrow Airport. Here, too, there's some further processing to produce the product to be sent out to hospitals. Molybdenum, the product sent from Johannesburg, has a half-life of 66 hours, long enough for the journey from South Africa, as long as there aren't any delays. Molybdenum's decay product is technetium-99, with a half-life of only 6 hours. This makes it particularly suitable for injecting into the human body by doctors diagnosing the malfunction of vital organs, because it becomes harmless in such a short time. It's technetium-99 which will be dispensed from the generators being packaged here. The plant sends out 1,000 units a week. At the Port Hope conversion facility on Lake Ontario, trucks arrive from the Blind River refinery. The ore, mined at McArthur River, has now been processed and refined into a product nearing the end of its journey, to the point where it can be turned into pellets for nuclear fuel. In Singapore port, the container, loaded with the overpack, which is itself loaded with the industrial tracers from Kuala Lumpur, lines up on the quayside ready to embark its cargo onto the ship bound for Australia. Containers with radioactive contents are last to be loaded. Shipping containers are held fast by an automatic locking system, where 4 lugs in each corner of the underside of the container fit into the 4 sockets on the corners of the top side of the container beneath it. As it's lowered into position, springs trigger the 4 lugs into the locked position. Still in Port Hope, the uranium has come here from the conversion facility to a fuel manufacturing facility, where it'll be turned into pellets, for subsequent insertion into these fuel rod assemblies. In this very pure form, it's negligibly radioactive, and the principal requirement is for cleanliness. These fuel rod assemblies lie at the heart of nuclear energy. A single uranium pellet, measuring about 20 millimeters in length, is equivalent to the energy produced by 807 kilograms of coal, 677 litres of oil, or 476 cubic meters of natural gas. About 8 pellets can provide an average home with enough electricity for an entire year. A technetium generator arrives at a hospital in England. A security officer from the hospital accompanies the delivery driver to the Department of Nuclear Medicine, and at the end of a radioactive material accounting procedure which began at the point of manufacture in South Africa, he signs the technetium into the hospital register. In a fully controlled environment, staff can now prepare the technetium for use with a patient. So, as the 3 different radioactive materials reach the end of their global transit, the carefully followed IAEA requirements and guidelines for the safe transport of radioactive material have ensured these products arrive with their end users safely, securely, and on time. The medical radioisotope, the technetium-99, injected into a patient and photographed on a gamma camera, provides a clear graphic illustration of which part of her heart is functioning correctly and which part isn't. The industrial tracers from Kuala Lumpur, nearing the end of their journey, will be used to check the metallurgical integrity of oil and gas pipelines, providing the people of Australia with a vital energy resource. And the uranium ore, mined originally from 640 metres beneath the northern plains of Canada, will be used to produce light and heat in cities and towns all over that country. This couldn't have happened without the movement of these goods over thousands of kilometres. But our story doesn't end here. Up to now, we've looked at the transport of radioactive material from the point of manufacture to the point of delivery to their end user. Of course, even after it has been used, radioactive material is still radioactive and is still considered to be dangerous goods. The material remains subject to the IAEA regulations for the safe transport of radioactive material while it is being transported into recycling or permanent waste storage. Here in France, spent fuel rod assemblies are being brought by train from a nuclear power plant to a dedicated, secure railway siding where they'll be disembarked onto a truck to be taken by road to a nearby reprocessing plant. The spent fuel is contained in purpose-built protective casks, each weighing up to 100 tons. The casks are kept inside outer casings fitted to the railway wagon. Each wagon is placarded with the radiation trefoil. Inside the dedicated secure yard, the wagons are shunted into a well-lit weatherproof building. Access to the disembarkation area is restricted to trained staff wearing approved protective clothing. The staff may look as if they're wearing baseball caps, but they are in fact regulation hard hats. The outer wagon casings are pulled back to reveal the cask. It's held in place by 4 steel trunnions at each of the 4 corners, locked into cradles mounted on the wagon. As the cradles are unlocked, the crane manoeuvres into position overhead. The trefoil is removed from the wagon as the cask is lifted out. Before its complete removal, the first of several wipe tests takes place to check for contamination. As the test reveals 0 contamination, the cask is lifted away from the wagon and lowered into a holding cradle. The road vehicle is a dedicated purpose-built truck, constructed with a cradle identical to that on the train wagon. Loading is the reverse of the earlier unloading procedure. The crane lifts the cask from the holding cradle to the cradle on the truck, when a further contamination wipe test is carried out and the trunnions locked into the cradle. If the wipe test proves no evidence of contamination, the truck's outer casing will be drawn over the cask and the truck is ready to depart. During this final stage, the drivers will carry out the paperwork handover, transferring responsibility and accountability from train to truck. Before leaving the dedicated rail terminal, further checks are made to ensure that external package readings comply with national and international safety regulations for the transport of radioactive material. Finally, with trefoils now applied, the truck departs for the radioactive waste processing plant. Some of the spent fuel components will be recycled and transported once again in their new life. And some will be transported just one last time to a facility for high-level waste disposal. Modern society can't function without and benefits enormously from radioactive material. Transport is an integral part of the life cycle of such material. By working with other international and national bodies on labelling and documentation, the design and testing of packages, on dose rate limits and activity limits for packages, and on requirements for the establishment of radiation protection programs and the provision of training, the IAEA helps ensure the authorized, safe, secure, sustainable, and uninterrupted transport of these vital goods all day, every day, for the 365 days of the year, as the world demands.